Hello everyone. Today's topic is finding last digit or unit digit of a number. Before finding the last digit or unit digit of a number, we need to know about the concept of cyclicity. Cyclicity is the state of something that occurs in cycles. For finding this last digit, we need to know the cyclicity of numbers from 0 to 9. So here, first the cyclicity of the numbers 0, 1, 5, 6 is 1. Because 1 raised to the power 1 is 1. Again 1 raised to the power 2, it's again 1. 1 raised to the power anything will be 1 itself. So its unit digit is going to be 1 only, as it's repeating after each interval, so therefore its cyclicity is 1. Similarly for 5 raised to the power 1 is 5, 5 raised to the power 2 is 25, where its last digit is 5, 5 raised to the power 3 is 125, where again its last digit is 5. Similarly for 6 raised to the power 1 is 6, raised to the power 6 is 36, again its unit digit is 6. 6 raised to the power 3 is 216, where its unit digit is 6 again. So here also we can see that it's repeating, the last digit is repeating after each interval, so its cyclicity is also 1. Now let us see some examples related to this. Example 1. Suppose we are given a question to find the unit digit of, say, 110 raised to the power 25. So its unit digit is going to be, find the unit digit of this. So its unit digit is nothing but 0, because its cyclicity is 1. Next, let us take another example. Suppose it's 25 raised to the power 112. We will just consider the unit digit. Here the unit digit is 5 raised to the power 112, raised to the power whatever, it will be 5 itself. Again any number ending in 6, if we are taking it to be 126 raised to the power 100, so here the unit digit is 6. 6 raised to the power anything is 6 itself. And another number that is ending in 1, so let us take 111 raised to the power 21. Here the unit digit is 1, raised to the power 21 is 1 itself. Here also we will consider just the last number, that is 0. So 0 raised to the power anything, its unit digit is 0. Here 7 raised to the power 1 is 7, 7 square is 49, so its unit digit is 9, 7 cube 343, its unit digit is 3, 7 to the power 4, 7 3 21, so its unit digit is going to be 1. Again 7 to the power 5, 1 into 7, so its unit digit is 7. And again 7 to the power 6, its unit digit is 9. So what we can see that after every fourth power of 7, the unit digit is going on repeating. So therefore its cyclicity is also 4. Similarly for 8 to the power 1 is 8, 8 square is 4, its unit digit is 4, 8 cube, its unit digit is 2, and 8 to the power 4 is, 8 to the power cube, its unit digit is 2, and 8 to the power 4, its unit digit is 6. After the fourth power of 8, we can see that the unit digit is repeating itself. 8 4. So similarly for 8 also the cyclicity is 4. Okay, so let us see some examples based upon this finding the last digit of a number ending in 2, 3, 7 or 8. So let us consider our first example as 132 raised to the power 71. If we are asked to find the last digit or unit digit of this number, then how we'll find this? See, we are going to ignore this 1 3. We will take only the last digit, that is 2, and 2 raised to the power 71. Now just because 2 cyclicity is 4, so therefore we are going to divide this 71 by 4. So when we divide 71 by 4, 4 1 is 4, and this is 31, 4 7 is 28, and this is remainder is 3. Whatever its remainder is, that we are going to write 2 to the power 3. So now 2 to the power 3 is 8, its unit digit is 8, so this is the answer. Next, if we take any example of 3, then suppose this is 113 raised to the power 44. Then similarly, again here also we will just take the last digit, the unit digit. For any question we are just going to consider the unit digit of that number. So that is 3, and here 44 is divisible by 4. So here the remainder will be what? 0. So whenever the remainder is 0, that time we are going to take the cyclicity of this number. Means here 2, 3, 7 and 8. For all these 4 numbers, we are going to take their cyclicity if their remainder is 0. So here we will write 4, and 3 raised to the power 4, its unit digit is 1. So let us take an example for a number ending in 4. So if we are taking, a number ending in 8. So if we are taking a number, suppose the number is 1, 8, 18 and raised to the power 146. Here the unit digit is 8 and the power is 146. Now we know that the cyclicity of 8 is 4. So according to the rule of divisibility, of 4, we check only the last 2 digits whether this is divisible by 4 or not. So when we will first consider 8 to the power 46. Now on dividing this 46 by 4, we are going to get the remainder as 2. Alright, so you can write it as 8 to the power 2. Now 8 to the power 2, its unit digit is 4. Next, for 7, let us consider a number ending in 7. If we are given to find the unit digit of this 7 raised to the power 18, then this can be written as 7 raised to the power 4 into 16 plus 2, which is equals to 7 to the power 2. We are only going to consider the remainder. This is the remainder. Next, let us see the cyclicity of 4 and 9. The cyclicity of 4 and 9 is 2, because 4 raised to the power 1 is 4, 4 square is 16, where its unit digit is 6, 4 cube is 64, where its unit digit is 4, and 4 to the power 4. Here again its unit digit is going to be 6. So what we can see, that the unit digit is going on repeating after every second power. So its cyclicity is 2. Similarly for 9, 9 raised to the power 1 is 9, 9 square is 81, where the unit digit is 1, and 9 cube, again its unit digit is 9, 9 to the power 4, again its last digit is 1. So from this, what we can conclude is, whenever any question is given to find the last digit of a number ending in 4 or 9, then there is a short trick that you can use to find its unit digit. That is, if the number is 4 and suppose the power is n, then its unit digit is going to be 4 if n is odd, and its unit digit is going to be 6 if n is even. For 9, similarly, if 9 is raised to the power n, then its unit digit is going to be 9 if n is odd, and its unit digit is going to be 1 if n is even. Let us consider some examples. Let us take an example 129 raised to the power 123. So here the unit digit is 9 and the power is 123, which is odd. So its unit digit is going to be 9. And for if you are taking another example, say 4 raised to the power 16, then here its power is even. So for even power, its unit digit is going to be 6. And for odd power, say if you are taking another example, 124 raised to the power 13, then here the unit digit is 4 raised to the power 13, which is odd. Then its unit digit is going to be 4. So here are certain questions from this topic. So the first question is find what is the unit digit of this. So here we can see that the cyclicity of 3 and 7 are 4. So therefore we can write it as when 65 is divided by 4, then we will get 4 1 and 25, 60 24 plus 1. The remainder is 1. Again, as we know that the cyclicity of 6 is 1, so 6 raised to the power anything is 6 is itself. So its unit digit is 6. And again, the cyclicity of 7 is 4. So we will be dividing 71 by 4. So we get 417 plus 3. Its remainder is 3. See, when we divide this by 4, 4 1 4, and this is 31, 7 28, and the remainder is 3. Therefore this is the thing. Now this can be written as 3 raised to the power 1 into 6 into 7 raised to the power 3. Now its unit digit is 3 and this is 6, and here 7 raised to the power 3, its unit digit is 3. So now 3 3 9 9 6 54. So its unit digit. See, in the next question we need to just multiply the unit digit. So here it's 4, next it's 8, next it's 7, and next it's 3. Now 4 8 ja 32, so its unit digit is 2. Again 2 7 ja 14, 4 4 3 12. So 2 is going to be its unit digit. Now let us see another question. Here we need to find the unit digit in the sum, this one. So we can see that this is, here the unit digit is 4. 4 raised to the power 372 plus again 4 raised to the power 373. Here the power is even and here the power is odd. So when the power is even, then the unit digit is 6, and when the power is odd, the unit digit is 4. So its unit digit is finally going to be 0. So here 0 is the correct answer. Thank you.